Right, guys, let's go through this then. So Noah starts investigating reaction times of athletes. He collects 50 data. Yeah, here's the reaction times, the lowest and the highest. Here are sums. So we've got the sum of all of them, the sum of everything squared, the number of people, the standard deviation, and the range. He decides to clean the data. He models reaction time using the distribution. Right. So we actually will need to work out what the mean is. Yeah, and then we're going to have to work out what's 3 standard deviations above and 3 standard deviations below. Now, there is obviously a lot of information here, and you need to ignore some of it. So mean, normally you'd add up all the scores, which is actually that one there, the sum of the scores. So it's going to be 88. I'm going to divide it by the amount of scores, which is 50, okay, which gives you 1.76. I've got my standard deviation as 1.05. So I want 3 of these. So I sort of like need to do plus or minus 3.15 to get my lower and my upper bound. Let's do the upper bound. So 1.76 plus 3.15 is 4.91. And my lower bound is going to be 1.76 minus 3.15, which is minus 1.39. Obviously, this is like hypothetical because going into minus numbers, and we're talking about reaction time, so it makes no sense. So which scores are above 4.91, which is these two, yeah. But so you'd have to say 5.3 and 5.7 are outliers, as they're 3 standard deviations above the mean. I've got to say, guys, it's important to have both of these numbers, or 4.91 and 0 as your lower bound. Yeah, you do get marks for that. Okay. Have we got any